Okay, this paper is May June 2021, paper 3, variant 3. Let's start off with the first question. This says expand 1 plus 3x power 2 over 3 in ascending powers of x up to and including the term in x cubed. So this is binomial expansion. Okay, there are various ways of doing binomial expansion. This is the way that I teach it. The first term is a power n, so 1 power 2 over 3. Term number 2 is n, a power n minus 1, b power 1. So I get 2 thirds, 1 power 2 third minus 1, and 3x power 1. Term number 3 is n minus 1 over 2 factorial, a power n minus 2, b power 2. So I get 2 thirds, 2 thirds minus 1 divided by 2 factorial, 3x squared. Term number 4 is n minus 1, n minus 2, 3 factorial, a power n minus 2, b power 2. So I get 2 thirds, 2 thirds minus 1, 2 thirds minus 2 over 3 factorial, 3x cubed. I will have to put each term on a calculator. This becomes 1. This was simple. This becomes 2x. Okay. Putting this on a calculator gives me 8 over 2 factorial gives me minus x squared. Then 27 gives me 4 over 3 x cubed. So the expansion is 1 plus 2x minus x squared plus 4 over 3x cubed. Okay, that's the correct answer. Moving on to question number 2. This says solve the equation this, giving your answer correct to 3 decimal places. This is an exponential equation. And these questions are solved by taking a substitution. So u equals to 4 power x. So I get u equals to 3 plus 1 over u. Solving this gives me u square equals to 3u plus 1, u square minus 3u minus 1 equals to 0. I should get two values for u by solving it uh, with the quadratic formula. So the two values of u are 3.303 and minus 0.303. Okay, replacing it with 4 power x. This is not possible. To solve this, I use an ln on both sides. And I get ln 3.303 divided by ln 4. I might get a rounding off error here because I've already rounded off. Let's see. I get x equals to 0.862. It's the correct answer. The next question is about parametric equations. So differentiation, parametric differentiation. It says x is given as this and y is given as this, where t is greater than minus 2, primarily because this has to be positive. express dy by dx in terms of t, you're simplifying your answer. So in order to find dy by dx, I need to first find dx by dt. Differentiating this expression gives me 1 plus 1 over t plus 2 into 1. And so this becomes 1 plus 1 over t plus 2. I can simplify this. I will possibly need to do that later on, so I'm just going to do it right now. This is my t plus 3 over t plus 2. Now for dy by dt, I need to use the product rule because I see a product of two expressions. U dash is 1, v dash is minus 2 e power minus 2t. Sorry, this is dy by dt. So u dash v plus v dash u. So I will simplify that later if I need to. For dy by dx, I'm going to use the chain rule. You might have learned the chain rule differently. This is how I do the chain rule, by simply just dividing two expressions, e power minus 2t minus 2 e power minus 2t into t minus 1 over t plus 3 over t plus 2. It says simplifying your answer, so I need to simplify this further as well. Let's see what I can simplify. I know that I can factor out an e power minus 2t in the new denominator, a new numerator. So I get 1 minus 2 times t minus 1. And can I write this as divided by t plus 3 over t plus 2? Okay, that gives me 1 minus 2t plus 2 multiplied by t plus 2 over t plus e minus 2t and 3 minus 2t. Okay, let me see if that's the correct answer. Yes, that's the correct answer in any simplified form. So you just need to simplify this. I think that's exactly what the question is asking you. Okay, then it says find the exact y coordinate of the stationary point. For the stationary point, what you need to do is equate dy by dx to 0. So I'm going to say 0 equals to e power minus 2t, 3 minus 2t, t plus 2, t plus 3. Suppose this gets equated to 0, then I have three factors. Either of those three factors could be equal to 0. I know that this can't be equals to 0 because it's not possible. 3 minus 2t equals to 0, so 3 equals to 2t, and t equals to 1.5. T plus 2 equals to 0, t equals to minus 2. This can't be true either because the question says that t has to be greater than minus 2. So I just have one answer, t equals to 1.5. I want to find the y coordinate. So putting it into the equation for y, I get t minus 1 e power minus 2t. So that gives me 1.5 minus 1 e power minus 2 into 1.5. That gives me 0.5 e power minus 3, which is 1 over 2 e power 3. So that's the correct answer. Okay. The next question is about partial fractions. The first part is partial fractions. These are simple linear denominators. So I'm going to say that 15 minus 6x over 1 plus 2x, 4 minus x equals to a over 1 plus 2x plus b over 4 minus x, a over a into 4 minus x plus b into 1 plus 2x. That should get rid of the denominator. Now, there are various ways to do partial fractions. I use a method called cover up where you equate the bracket to 0. So if I take x equals to 4, this gets equated to 0. So b equals to -1. And x equals to -12. That is going to equate this back to 0. So I get 15 minus 6 into -12, a 4 minus -12. (4.5), and this gives me a equals to 4. Let me check, and b equals to -1. So my expressions are 4 over 1 plus 2x minus 1 over 4 minus x. Then it says integrate both of these, giving you an answer in the form this. It's a 4-mark question with very little space. So I'm going to integrate it carefully. So this becomes 4 ln 1 plus 2x divided by 2 minus ln 4 minus x divided by -1. So I get 2 ln 1 plus 2x plus ln 4 minus x. Okay. Then applying the limits 1 and 2. Either I can first combine these as well and then apply the limits. I think it's easier if I combine these first and then apply the limits. This becomes ln 1 plus 2x squared into 4 minus x. And then I need to apply the limits. What are my limits? My limits are 2, which gives me 4 inside the bracket, and minus ln 2 squared. So I get ln 25 into 2 is 50 minus ln 9 into 3 is 27. So I get ln 50 over 27. Unusual, but let's see if that's the correct answer. Yes, that's the correct answer. Okay. Then it says by, this is trigonometry. By first expanding this, show that the equation this can be expressed as tan power 4 theta. So tan 4 theta goes to half tan theta. I need to first break it using compound angles. 2 theta plus 2 theta. So this becomes tan 2 theta plus tan 2 theta 1 minus tan 2 theta tan 2 theta equals to half tan theta. When I have too many fractions, I have a habit of writing them differently. Tan 2 theta can be written, let's first just add it up. 2 tan 2 theta, 2 theta, and 1 minus tan squared 2 theta. Okay, I can also cross multiply this to make it easier. I think that would be the better way to do it. 4. So tan 2 theta is 2 tan theta over 1 minus tan square theta. And again, tan 2 theta is 2 tan theta over 1 minus tan square theta. This being squared again. So let's see what that becomes. This becomes 8 tan theta. Okay, taking a common denominator gives me there's a small mistake that I might have done, and it's going to lead to an issue later on. I'm just going to take this. Let me just solve this part again to make sure that I solve it in an easier way rather than making it more complicated. So this becomes 4 tan square theta, and this becomes 1 minus tan square theta whole square. Okay, so taking a common denominator gives me 1 minus tan square theta whole square minus 4 tan square theta. And what I have in the denominator is 1 minus tan square theta whole square. Okay, what I see is that some things are being cancelled out, and I should do that so as to reduce the fractions that I have. Okay, that gives me 8. Now I'm going to expand the numerator 1 minus 2 tan square theta plus tan power 4 theta minus 4 tan square theta. And I have this in the denominator 1 minus 2 tan square theta plus tan 4 theta. Then I cross multiply 8 minus 16 tan square theta plus 8 tan power 4 theta equals to 1 minus 2 tan square theta, 1 minus 6 tan square theta, sorry, plus tan power 4 theta. Okay. I'm sorry, this is again a mistake here. I didn't have to expand that. So it's 1 minus tan square theta. So I get 8 minus 8 tan square theta. Okay, so tan power 4 theta minus 6 tan square theta plus 8 tan square theta plus 1 minus 8. So I get tan power 4 theta plus 2 tan square theta minus 7. Those That is what the question was asking me to prove. That says hence solve the equation tan power 4 theta equals to half tan theta. So this is the equation that you just simplified. So you could pick up that expression and say that tan power 4 theta plus 2 tan square theta minus 7 equals to 0. Solving it using the quadratic formula gives me two answers. One is tan square theta equals to 1.828. Since this is a disguised quadratic equation, I'm getting answers for this 3.828. Now, this is not possible. For the other one, I'm going to take a root on both sides and say that tan theta equals to root of 1.828 or tan theta equals to minus root of 1.828. This gives me answers in the first quadrant. This gives me answers in the second quadrant, since the range is from 0 to 180. Alpha is going to be the same for both, so tan inverse of root of 1.828. Just check if I'm doing it correctly. It doesn't say anywhere, so I will have to go with that. Uh, there seems to be a problem in the numbers that I've written. Let me just check my numbers again. I had a feeling I was making an error. Okay, no, I think That's fine. 53.5. Quadrant 1 is theta equals to 53.5. Quadrant 2 is theta equals to 180 minus 53.5. 126.5. Okay. This says by sketching a suitable pair of graphs, show that the equation this has exactly one root in the interval x from 0 to pi. So I'm going to make a rough sketch. This can't be exact since I don't have a ruler on this. Okay, so let's mark this as pi over 2, and that is pi. The graph of cot x looks something like this. Okay, it goes to infinity at pi. For 1 plus e power minus x, the graph of e power minus x looks something like that. With 1 plus, it's going to intersect at 2 and go down like that. Okay, so there is exactly one root between the two. One intersection point. We just have to write that, one intersection point. Okay, this graph should technically start from here only. That tells you there's just one intersection. Verify by calculation. Whenever this says this, what you need to do is you need to gather your equation on one side first and create a function. So my function is going to be cot. Okay, my bad. Sorry, I didn't see that this was half x. So this graph will look different. Sorry, I didn't realize that earlier. This graph is going to look like that. And this graph is correct. Okay, half x means that it's stretched horizontally. So bringing everything on one side gives me cot half x minus 1 minus e power minus x. Okay, and then verifying, putting my calculator into radian mode and calculating these two. F of 1 and f of 1.5. Cot. So I'm going to write on my calculator, I'm going to write 1 over tan of 0.5 minus 1 minus e power minus 1. My calculator needs to be in radians. It gives me 0.462. Then using that, using one it gives me minus 0.1497. So change of sign indicates root. Okay. Then it says use an iterative formula on this to determine corrected two decimal places. So I'm going to start off with x1 equals to 1.25, the midpoint of the interval that I just proved. I'm going to use my calculator to do these iterations. 1.3215, that rounds off to 1.32, then 1.3365 rounds off to 1.34, then 1.3396, that rounds off to 1.34, then 1.3402, that also rounds off to 1.34. So I think I have my answer, that is 1.34. I have my iterations, all the iterations that I needed. Okay, the next question says for the curve shown in the diagram, the normal to the curve at the point P with coordinates x comma y meets the x-axis at n. The point M is the foot of the perpendicular from P to the x-axis. So there's a perpendicular line, which means that there must be a normal here, a tangent and a normal here. The curve is such that for all values of x in the interval x between the area of triangle PMN is equal to tan x. So area of triangle, we just write that separately. PMN is equals to tan x. Right now, I'm not concerned with tan x. I'm just concerned with dy over dx. Okay, so let's look at what dy over dx might be. Dy over dx is the gradient of tangent. This point is x comma y. This means that this is the y coordinate and this is the x coordinate. If I were to write this as rise over run, so dy over minus dx over dy, which is the gradient of normal, should be equal to the gradient of Pn. Now, in order to calculate the gradient of Pn, can I say that as I move from P to N, the line is falling, so the rise is negative minus y, and the line is running Mn minus dx over dy, sorry. The negative reciprocal of the gradient of the tangent. I cancel this and I take a reciprocal on both sides, and that gives me Mn over y. I'm relying on the idea that the gradient of the normal is minus dx over dy, which is the negative reciprocal of dy by dx. Unusual question for 1 mark. Let's see what the marking scheme says. It says justify the given statements, or whatever justification you might have. Okay. Hence show that x and y satisfy the differential equation. So the other thing that the question was telling you, that the area of triangle PMN is equals to tan x. Let's think about this. Half into base Mn, and the height is y, is equals to tan x. Now, can I replace Mn with, if dy over dx was equals to Mn over y, can I replace Mn with y dy over dx? So I get half y dy over dx into y equals to tan x. So I get y squared dy by dx equals to half equals to tan x. That is the solution for the second part. For the third part, it says solve the differential equation, find the equation of the curve expressing y and x. So whenever you're solving differential equations, your first step is always separation of variables. So I'm going to take 2 to the other side and dx to the other side as well. And to integrate on both sides, I get y cubed divided by 3. The integration of tan x is minus ln cos x. I can put a plus c on either side, it doesn't matter. Then trying to find c, 1 over 3 minus 2 ln cos of 0. Okay, minus 2 ln 1. So C is 1/3. Now I need to make y the subject of the equation. So I'm going to say y cube over 3 minus 2 ln cos x plus 1/3. Multiplying, cross multiplying gives me minus 6 ln cos x plus 1. And then a cube root. Okay. Question number 8 shows me a curve and says, and it's a maximum point m. So I think this might be a question on differentiation. So when I'm differentiating it, I'm going to use the quotient rule. U equals to ln x, v equals to x power 4, v dash is 4x cubed, u dash is 1 over x. Using my quotient rule gives me u dash v minus v dash u cancels out over v squared. Since I have to equate this to 0, if I'm finding the maximum point, I can actually get rid of the denominator that goes there and multiplies. So it equates to 0. I have x cubed minus 4x cubed ln x. So either x cubed equals to 0. So x equals to 0. That might not be true because uh, I don't see at any point at 0. And x can't be 0 because the term becomes undefined. So 1 equals to 4 ln x. Okay. So e power 1 over 4 is the x coordinate. In order to find the y coordinate, I can just plug it in. Ln e power 1 over 4, e power 1 over 4, power 4. That gives me 1 over 4 ln e over e. So this is me 1 over 4 e. So the coordinates of m are e power 1 over 4, comma 1 over 4 e. Yes, that's the correct answer. Then says by using integration by parts, show that for all a greater than 1, the integration of dx is less than 1 over 9. Okay, let's first concentrate on the integration. Can I write this expression as ln x and x power minus 4? So using ILATE, I have a logarithmic and an algebraic. So the first one in that order is called u, the other one is called v dash. So I get integration and integration again, then vu minus vu dash. Vu minus vu dash. Okay, simplifying the expression inside first, this becomes a plus 1/3 outside, and this becomes minus 3 minus 1 is minus 4. So again integrate this and I get what? X power minus 3 over minus 3. So this becomes minus x power minus 3 over 9. And this one is minus x power minus 3 over 3 ln x. And I have limits from 1 to a. Now show that for all a greater than 1, the integral is less than 1 over 9. So let's just first put in the limits, see what happens. This becomes 0 and this becomes minus 1 over 9. Okay. Since this is less than 1 over 9, that is what I have to prove. If I have two negative terms here, that means I'm subtracting something from 1 over 9. Will lead to overall answer less than 1 over 9 for all values of a. Okay, that's the justification for the statement. Okay, this is a question on vectors. Let me just see how many more questions to go. It's two more questions to go. It says the quadrilateral ABCD is a trapezium in which AB, DC are parallel. Okay, AB and DC are parallel. I don't know where they are exactly, but I'm just doing that with respect to the origin O, the position vectors of OA. I have a habit of writing them vertically. OB, OC. Given that DC is equals to 3 times AB, this question is simple then, breaking down vectors, OC minus OD, and I can calculate OB minus OA. I can calculate AB. So OB minus OA gives me 1 minus 1 gives me 2, 3 minus 2 gives me 1, and 1 minus 3 gives me minus 2. And OC is, so I get 2, 2 minus 3. And if I bring this to this side, 6, 3, and minus 6 equals to OD. So I get OD equals to minus 4, minus 1, and 3. Check. Yes. There's a state a vector equation for the line through A and B. So a line through A and B will have the directional vector of AB, 2, 1, and minus 2, 2, 1, minus 2. I'm going to take A's coordinates, minus 1, 2, and 3, plus lambda times 2, 1, and minus 2. Then it says find the distance between the parallel sides and hence find the area of the trapezium. Okay, so I don't know how they are parallel, but what I should do is I could find out CD first. Since I have AB, let's find out CD. Or I could simply do this. I don't think I need CD. I have the vector equation of the line AB. Okay. And I could say that this is the point D. What I'm trying to find is, or let's, AB is parallel to DC. Okay. This is the line DC. So let's say I have the vector equation of this line. What I simply need to do is pick out any point. Let's pick out the point C and find the perpendicular distance that's called CX. That would give me the height of the trapezium. Okay. So if the vector equation of the line AB is minus 1, 2, and 3 plus lambda times 2, 1, and minus 2, I could say that X has the general coordinate minus 1 plus 2 lambda, 2 plus lambda, and 3 minus 2 lambda. I know that CX is perpendicular to CD. Okay, let's calculate CD on the side quickly. OD minus OC, or I already have DC, I think. Let me just see that. I said DC is equals to 3 times AB. So I could do that directly. DC 3 times AB, or CD is minus 3 times AB. So minus 3 times 2, 1 and minus 2 gives me minus 6, minus 3 and 6. So I can say that CX is perpendicular. Actually, I didn't really need that. CX is perpendicular to direction of AB. So I can say that CX is therefore OX minus OC. I will need that CD later for the area. So that's fine if I calculated that right now. And OC, let me just check what OC is. OC is 2, 2 and minus 3. So OX minus OC, 2 plus lambda minus OC, and 3 minus 2 lambda plus 3. Okay. I get 2 lambda minus 3 lambda and 6 minus 2 lambda. So CX has to be perpendicular to 2, 1 minus 2, AB equals to 0. So 4 lambda minus 6 plus lambda minus 12 plus 4 lambda equals to 0. I get 9 lambda equals to 18, lambda equals to 2. So I was trying to find the distance. So I'm going to say that CX is therefore the distance. CX is 2 lambda minus 3, 2, and 6 minus 2 times 2. That gives me 1, 2, and 2. So the distance CX, 1 square, 2 square, 2 square. That gives me 3. So the area is half height to sum of parallel sides. Okay. So parallel sides are AB and CD. I don't have the distances. So let's calculate the distances. AB is root of 2 square, 1 square, and minus 2 square. That gives me 3 again. And since DC is 3 times, so I think that should come out as 9. 36 plus 36 plus 9. Okay, so gives me half into 3 into 3 plus 9. 12 into 3, 36 gives me 18. That is the correct answer. Okay, then this question says verify this is a root. So I need to plug that in, minus 1 plus root 2i power 4 minus 1 plus root 2i squared minus 1 plus root 2i plus 12. So I'm going to simplify this first, taking a whole square, just rearranging it first so that it's clearer. When I take a squared to ab plus b squared. So this gives me minus 2 root 2i plus 1 minus 1 minus root 2 root 2i. So I know that the square of this is minus 1 minus root 2i. So this can become minus 1 minus 2 root 2i all squared. Now I can factor out a minus in this and say that this becomes 1 plus 2 root 2i. And the entire thing squared. Minus gets squared and I'm left with 1 plus 2 root 2i squared. So 1 plus 4 root 2i plus 8i squared. 1 plus 4 root 2i minus 8 minus 3 plus 6 to root 2i, and bringing this further as well, minus 2 minus plus 2 root 2i plus 12 minus plus 10 plus 2 root 2i. So
plus 10 plus 2 root 2i. Here is possibly the mistake of a sign. This is minus. So I see that everything is going down to 0. This gives me 11. This also gives me 11. This gives me 6 root 2i and 6 root 2i. So that becomes 0. Then it says find the other roots, which is the challenging part. So let's do that. If one root is minus 1 plus root 2i, then the other must be minus 1 minus root 2i. Okay, using the strategy for comparison, I'm going to say that I have these two roots. And I have unknown roots. Okay. First, multiplying these across gives me z squared plus z plus root 2 zi. Okay, it's going to be easier if I write these as x because z resembles 2 a lot and I'm bound to make an error there. So just going to replace everything with an x so that it's more comfortable for me. There's no compulsion there, but that is what I want to do. X squared plus x plus root 2 x I plus x plus 1 plus root 2i minus x root 2i minus root 2i minus 2i squared. And I have ax squared plus bx plus c. So I think some things must cancel out. This cancels out with that. This cancels out with that. So I'm left with x squared plus 2x plus 1. And this becomes plus 2. So x squared plus 2x plus 3. And I have ax squared plus bx plus c. Now I'm going to take this to the next page so that it's easier to do. Okay. Expanding this gives me ax power 4, bx cubed, cx squared, 2ax cubed, 2 bx squared, 2c, 2acx plus 3ax squared, 3bx plus 3c. Now some of these are easy. A is therefore equal to 1. 12 is 3c. C is 4. And this is x. 2 is equals to 2c plus 3b. Okay, so my expression is x squared minus 2x plus 4, and I already have these two roots. Finding the other two roots means that I need to equate this to 0. X square minus 2x plus 4 equals to 0. So let me just check if I'm doing it correctly so that I don't have an error at the end. I've done it correctly so far. 1 minus 2, 4. So I get two more non-real roots, 1 plus root 3i and 1 minus root 3i. So those are the other two roots. I could call these z now. Okay, that's the end of the exam.